episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor. Welcome everybody again to another episode of our show with another really fascinating guest today, helping to create a better tomorrow on many different fronts. Today on the show, we have the honor of being joined by Dr. Jonna Mazet, who is a professor of epidemiology and disease ecology at the UC Davis School of Veterinary Medicine and founding executive director of the UC Davis One Health Institute. Additionally, Dr. Mazet is on the steering committee of the Global Virome Project, principal investigator of the PREDICT Project, chair of the National Academies One Health Action Collaborative, and co-vice chair, UC Global Health Institute Board of Directors. Her work focuses on the global health problem solving for emerging infectious diseases and conservation challenges, and she's active in international One Health education, service, and research programs, most notably in relation to pathogen emergence, disease transmission among wildlife, domestic animals, and people, and the ecological drivers of these novel disease dynamics. Dr. Mazet is a co-director of the U.S. Agency for the International Development's One Health Workforce Next Generation Initiative, which is an $85 million educational strengthening project to empower professionals in Central and East Africa and Southeast Asia to address complex and emerging health threats, including antimicrobial resistance and zoonotic diseases. She's also the principal investigator of and served as the global director of the PREDICT Project for the last 10 years, which was a greater than $200 million viral emergence early warning project under USAID's Emerging Pandemic Threat Division, which served as an early warning system strengthening effort at finding emerging viruses before they spread to humans. Dr. Mazet was elected to the U.S. National Academy of Medicine in 2013 in recognition for her various approaches to emerging and environmental and global health threats. She serves on the National Academy of Science, Engineering, Medicine's Forum on Microbial Threats and chairs the Academy's One Health Action Collaborative. And she was appointed to the National Academy's Standing Committee on Emerging Infectious Diseases and 21st Century Health Threats, created to assist the federal government with critical science and policy issues related to COVID-19 and other emerging health threats. Wow. Dr. Jonna Mazet, thanks so much for taking the time to go on the show today.
Oh, well, it's an honor to be here. Thanks for having me.
Yeah, it's a very exciting having you, a very exciting set of topics we're going to be getting into. However, I'd love to start things off like we typically do, just by handing you the floor for a few minutes to a little further introduce yourself, everything from sort of, where you grew up, how you got interested in veterinary medicine, epidemiology, and a little your early career path. I think that'd be a great way to start things off.
Well, thanks. Actually, that was a lovely introduction. I really appreciate it. But last week I did take a new position. I'm now Vice Provost of Grand Challenges for UC Davis. So building on all of those things that you just mentioned, I'm now trying to really take as a whole institutional approach this One Health philosophy that I think of as One Health for the planet, not just for people on the planet. And I do believe that past work in conservation and pandemics and pandemic prevention are really pointing us to see that the impact that we're having on the earth is a bit devastating, and it's evidenced, if we ever needed it to be proven to us, it's evidenced by us having to be sheltering and doing all of the prevention work that we're doing now to try to get out of this pandemic, and the dramatic and devastating losses that we've had in lives and economies and mental health, emotional strength. So I really appreciate you having me and talking to you, because I think if we can band together and think about how we walk on this earth, we can actually reduce impacts for more than one great consequential problem than if we're all working separately and sort of just chipping away at the edges.
Absolutely. Absolutely. And working off of that, you mentioned sort of the interconnection and the concept of One Health. And I pulled this WHO definition off the internet before we got together. So they mentioned One Health is a collaborative, multi-sectoral, and transdisciplinary approach, working local, regional, national, and global levels with the goal of achieving optimal health outcomes, recognizing the interconnection between people, animals, plants, and their shared environment. Talk for a couple of minutes about the One Health concept, when it started, where it came from, and a little bit of that, if you would, just to sort of lay the background for a lot of other things we're going to be getting into.
Absolutely. So for me, I use the One Health approach. I think about two central tenets, and I love that definition. It took a long time to come to a consensus around definitions. I think a lot of us out there were using the One Health approach while the definitions were being, discussed for decades. So that's fine. The central tenets around One Health that I think are most important is that we're thinking about that holistic, interconnected health of all of the inhabitants of Earth, including the environmental supports for those inhabitants, and that we're being collaborative. And so no one organization or individual can really have the big discoveries that can fix the planetary problems and societal problems. We need to work together, and we need to do it more efficiently. And I think in the One Health approach, we've done quite well with the human health and animal health sides, and that probably has to do with the history that I can talk about a little bit. We've done less well with the environmental and the plant piece being pulled out specifically out of the environmental piece where they were lumped before, I think is also an important move. Points to the importance of plants for our oxygen, but also for our food security. So those are some, I think, central tenets that I think about, again, as One Health as an approach to problem solving rather than as a new discipline or something that we're working in. Now, historically, again, I think many people were working in this field and using this approach before it was named One Health, or before it was accepted as that name. We heard eco health, ecosystem health, conservation medicine, but none of those really captured holistically that feel of what One Health is. And it kind of put an emphasis on one area or another. And my first recognition that I was supporting the name One Health in the way that a lot of us were doing business was in 2001 in Johannesburg, South Africa, where pushed and instigated by the Wildlife Conservation Society, the Wildlife Disease Association, for which I was working as a scientific program chair for the international conference, together with the Society for Tropical Veterinary Medicine, came together to issue a One Health resolution. And then following that, there were some really major efforts, again, mostly really facilitated and pushed by Wildlife Conservation Society to bring together the conservation and health people in New York City with the New York Department of Health. And my friend and colleague, Billy Karish, famously was speaking about Ebola and said it's all just One Health. And I think that's where it really started to take off, is when he coined it in that way. And so since then, there's just been this growing movement and a lot of support from the veterinary community and the human medicine community. But if we look back to the 1950s and 1960s, we see actually veterinarians working in this realm. At my institution, Calvin Schwabe started a whole One Medicine program in the 60s and really was writing textbooks about it and built programs that I was trained in that were jointly administered by the medical school, the veterinary school, and the Division of Statistics, and then brought in lots of other programs to train epidemiologists. So I didn't even know it, but when I was being trained in the early 90s, I was immersed in One Health. We just didn't call it that.
Excellent. And Johnny, You, as mentioned in the intro, you're a PI, also the global director of the Predict project. Got started back in, I believe, 2009. 30 countries, 60 laboratories set up in these extremely risky areas. And we'll get it a little later on. We'll get into the algorithm and sort of how you created, the spillover projects separate from Predict. But what led to the initial? Was it 2009? Was it Ebola? Was it other zoonotic disease that sort of said, "Hey, we have to invest this 200 million and get these labs going"? Well, give us a little bit of background on Predict and where the whole idea came from. And setting
Sure. And here I have to give credit to the U.S. Agency for International Development, as Dennis Carroll was the lead of what was the Emerging Pandemic Threats Division, became Emerging Threats Division. And he was really following the science. He was following what I and other colleagues at EcoHealth Alliance were doing, and other people around the world, and saying, hey, we need to invest in this One Health approach. I also believe, and this is anecdotal, but I believe that USAID was fatiguing a bit of throwing vaccine at problems, really supporting international outbreak responses too late. So they would be called in too late. They would be providing vaccine too late. And again, we have our current situation to be able to really feel that personally. But this was happening for known diseases all over the world, that they would come in and help with yellow fever vaccination almost at the end of the outbreak, because that's how long it took to mobilize. And they really wanted to get in front of these disease problems instead of responding too late. And the program really grew out of the avian influenza work. So they had been investing quite some time in avian influenza and saying, wow, well, it's not just birds and flu we need to worry about. We need to worry about disease X and what might come next. And that was a full decade before WHO and others were accepting and putting disease X into the paradigm. So that's really where it came from. They decided to invest in what a lot of us were doing at very small levels. And they said, let's see if we can really make a difference by properly investing in this One Health approach and a prevention and preparedness paradigm versus response. So they initially put out for public bid the first 5 years of the Predict project, and groups came together to start to build consortia. And our consortia with those partners I mentioned, as well as Smithsonian Institution and many others, came together to form a bid. And we were really almost reluctant bidders, in that we wanted to see this done, and we felt like we had been pushing for this One Health approach, so we needed to be in the mix. But it looked like a huge challenge to jump in and say, yes, we can find and stop diseases before they become epidemics and pandemics, when we don't have any diagnostic capacity to do that. We don't know if the countries yet will be wanting to do that. But we jumped in, and a big reason we jumped in also was that we felt that other groups that might bid for it, that were working in this frame, were not necessarily using a conservation-oriented approach. And we wanted to make sure that the thousands, it turns out we sampled 164,000 individuals in the Predict project. We didn't want, for the wildlife especially, we didn't want those animals to be killed and sampled. We wanted to do it in a ethical, responsible, and life-preserving way.
And you mentioned 164,000 animals and people. You had a lot of success over the decade. 1,200 potentially zoonotic viruses, 160 coronaviruses, including things that looked like SARS and MERS. You recently published in the National Academy of Sciences journal the publication ranking the risk of animal to human spillover for newly discovered viruses. And here you have what I term the Predict algorithm, which has led to this spillover tool where you do an exceptional amount of ranking, looking at everything from issues about the viruses to the hosts, where they can live, where they can multiply, the environment, human behavior. A lot of stuff goes into deciding if virus X is going to kill me or just hang out in me and be happy and I'll be fine. Talk a little bit about sort of how you go about prioritizing everything that is in the predict algorithm, and then ultimately take us into the spillover tool, because this is a fascinating, some of this open source tool for everyone to use now, sort of like a credit report on viruses. Walk us through this a bit, if you would.
Yeah, absolutely. So one of the things we were doing with Predict was really strengthening the capacity. Again, USAID's philosophy is you work with the country, strengthen capacity. We learn from our interactions. They get technology transfer and support from the American people to really strengthen the systems to detect, discover, and respond to these early warnings and threats. But it's working with the countries, their governments, and their people to set up. And we didn't actually develop new laboratories. We worked with the laboratories in the countries to make sure that they had the capacity to do that work. Well, while we're strengthening those systems, of course, the objective is being achieved, and we're discovering and detecting those viruses. We're detecting known viruses in more hosts and more locations, finding things like Marburg in West Africa when they didn't know they had Marburg. That's a huge outcome, because maybe we did catch it before somebody got sick. Probably people were getting sick and going undiagnosed. And so what we were able to do is make sure their laboratories and their clinicians were looking for Marburg. It was on the differential diagnosis list for their doctors. So if you think about the terrible West Africa Ebola outbreak, Ebola wasn't on the list. They didn't think they had it there. So this is what we're trying to do, is not just find the new viruses, the disease X ahead of time, but also make sure that people know what's in their area and are ready for it. That discovery, both Marburg, and we found a new Ebola virus in West Africa, those provided also proof of concept that if you know the hosts of these viruses and the distribution of those hosts, then you should expect the viruses there. And we did know that the hosts for Ebola and Marburg were in Sierra Leone, for example, and then we found those viruses. And so that helped us. And then when we found the new Ebola, we said, let's see if this works. Where are the distribution of those hosts? And very soon after, other scientists found the one we found in Sierra Leone, found it in Kenya, because the hosts go all the way across Africa. Others found it in Guinea. Then our team found it in Guinea. Then we found it serologically in DRC. So if we know the hosts and their interactions with the viruses, we can do a couple things. We can reduce our risk, and we can start to map and help the public health systems and the doctors be ready for them. So as we're discovering those viruses, it really showed us that we had to be responsible with all these new ones. How do we inform around the risk? Are these important viruses? Are they unimportant viruses? Do we just say, here you go, you have some new viruses, or do we help put some interpretation around that? And that was a big challenge throughout. The Predict started about 12 years ago, as you mentioned, in 2009. It ended last September. It went through 2 5-year bidding cycles, which the second 5 years was amazing to even have a second cycle. Then when the pandemic hit, we were shutting down, and they gave us a year extension. So we actually went for 11 years because our teams were supporting the pandemic response in their countries. So the spillover tool is a legacy from Predict. I don't see it as really separate, but I hope it will grow and be its own crowd sciencing public health platform that wouldn't have happened if we hadn't been discovering all this virus and needing to put some interpretation around them. So one thing that is really different about the spillover tool than the way people have thought about viruses and spillover risk until now is that we added not just the virological sort of characteristics that had been looked at before, but we added the epidemiological and ecological circumstances. So we looked at the hosts. We looked at the way people were interacting with those hosts. We looked at the way land use was changing. And then on the virus side, even we were bringing in the newer science like host plasticity that some of our team members really discovered. And Christine Croiter-Johnson, our head of surveillance, really led that effort to say, okay, if viruses are found in many hosts and those hosts are quite different from each other, then that virus has even more propensity to be able to jump into people. So that became a very highly ranked risk factor. So in all, we looked at about 40 risk factors that we identified in PREDICT or we identified in the literature. And then we went out to the scientific community working all over the world in this realm and had them provide their expert opinion to help us start a risk ranking paradigm. And you can go to www.spillover.global and you can look at the rankings. You can create a customized watch list for whatever you might be interested in. For example, if you're a policymaker in Uganda, you can just make a Uganda watch list. If you're mostly a researcher in coronaviruses, you can just make a coronavirus watch list. So it's fully customizable. Most importantly, it's a way for scientists like me and others all over the world that are discovering virus to start putting their viruses into the public domain and ranking them without waiting the 2 years for the publication cycle.
Outstanding. And so, PREDICT is at the end of its cycle, but it's provided now the basis for something much bigger, global Virome project. And here I have to go back to this kind of sobering information I talked about with our mutual friend Suzanne Murray, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, report on biodiversity and pandemics, 1.7 million currently undiscovered viruses thought to exist in mammals and avian hosts alone, somewhere between 600,000 and 800,000 potentially can affect humans. So a lot more to be done. Global Virome project, the next step in this, where you're going to go after many more. Talk about that. I saw sort of an estimated budget of a few $1 billion here. Walk us through what's going on with the Global Virome project.
Yeah, and another just little pride point, all those numbers you mentioned, those all come from PREDICT and our PREDICT data. And we did that analysis, published it a few years ago in Science, and glad to see that our governmental bodies are taking note. And absolutely. WHO took note, NIH took note, OIE, which is the WHO for animals, and FAO, the Food and Agriculture Organization. We're all working together and basically volunteering behind this initiative to build momentum for a global Virome project. And what we mean by that is it is time to know as much about viruses as we know about bacteria. And we have within our power to do that. The budget to get the majority of those viruses and discover them and begin just a bit of characterization to be able to put them on the watch list, that's about $1 billion. If you wanted to keep discovering, so as you discover virus, you find more and more virus in each species. As the viruses become more rare, you sort of flatten out and it gets really expensive out in the tail to identify the last few viruses. If you want to try and get all of those, cost about $4 billion. Now, when I used to have this conversation with people, their eyes would get big and not WHO, though they were like, yeah, $4 billion, that's not that much compared to what's going on. And they were right? Because they and the World Bank had been estimating that we would spend trillions of dollars on these emerging infectious diseases. And now we are living in a multi-trillion dollar example of what can happen if you don't get ready in advance. So really, even before that, every time we had a big regional kind of epidemic, it was costing around $40 billion on average. And so we're talking about, even if we went all the way to the big number, we were still at 10%. of one of those events. And we anticipated that if everybody jumped in and started working on it, it could be accomplished in 10 years. And so, then you're at 1% per year of what a single outbreak was costing. And again, just a tiny fraction of what this one costs. Now, finding all the viruses ahead of time doesn't mean you're going to stop every spillover. It doesn't mean you're going to stop every epidemic. I think, and I believe that it does mean that we could prevent pandemics, though, because as you are building that system, as countries are all understanding what their viruses are in their countries, they are building the capacity to detect and diagnose them. And so then we have the ability to actually identify viruses when they happen, because people are watching at their source and jump in and do the good public health practices that can control them before they spread. And that's I think, the real power. Though we're already seeing that there are diagnostic pipelines that are being built, there are vaccine pipelines that are being built, there are drug discovery targets that can be identified. So kind of, we use the analogy like the Human Genome Project, that it had a very finite goal, but the spin-offs were so productive that they swamped out really the finite goal of the original project. And I think that the Global Virome Project has that potential.
Really cool. Really cool. And this diagnostic vaccine, antiviral discovery pipeline is a fascinating thing. If we had it only 2 years ago, we might be in a very different position. And yeah, you said $4 billion is meaningless in the middle of a pandemic that's cost ever 30 trillion or whatever it's cost us to date. I want to talk, I'd like to talk a little bit more, obviously, sort of a little more future thinking here in terms, you gave this presentation, it was a TED talk, I think, last year. It was entitled, "What if we could immunize the world against pandemics?" And it got me, I had this, about a year ago, I got to spend some time with Linfa Wang down in Singapore, colloquially known as the Batman. Spends a lot of time with viruses down that way. And he had this very interesting story about this disease called Hendra. It's not a coronavirus. It's something called a paramyxovirus, whatever. You know about that than I do. But kills people pretty bad, quickly. Infects a lot of horses, and he had this very elegant story about them vaccinating all the horses, and then all the Hendra went away. All the Hendra deaths in humans. Talk about sort of that model a little bit, because here, sort of, coming back to this One Health approach. Here, you're intervening in the host, or not the host, the carrier or the intermediaries. Could we be doing more of that with the Global Virome Project?
Yeah, and that TED talk was in 2018. So,
Okay.
So way before the pandemic,
Gotcha.
we were trying to get people to notice that we could do this early. And Linfa is a great colleague, an amazing scientist, and he's paramyxoviruses include measles. So how deadly measles is, right? Yep. So that's in the paramyxo family. And there are great examples. Hendra, that you just discussed from Australia, that's one where we should recognize we have early warning signs in fact in horses, and veterinarians were noticing the problems. And then the spillover event. Another one that people know a lot about is Nipah virus. It's also a paramyxovirus, very similar to Hendra virus. And that is a really interesting and amazing story where people were getting really sick with a mystery disease. There was actually other species involved, pigs, and even a feature film made off of that story, though most people didn't know Contagion, that movie, was actually off of the Nipah story. And so exactly what we were talking about with One Health, the wildlife and environmental aspect was intersecting actually with the agricultural and the pig farming, and then the human behavior, where the people in the area where Nipah was being found like to drink date palm sap. It's a wonderful juice. You can also make alcohol out of it, but even most people drink it raw as a fresh juice. And while the pigs and the bats kind of like to hang out around those date palms, and because they like it too, right? And so it's this perfect intersection. And the lovely thing about the Nipah story is, though it took some time to figure out what was going on, the intervention, once it was known, prevents it. So people recognized that not only could you get Nipah virus, actually, frankly, just putting out the preventive messages, the PSAs about Nipah and don't drink date palm sap, that didn't work, because culturally and taste-wise, people like to eat drink date palm sap. But what did work was videos and noticing, and the people who harvest the sap noticing that the bats were fouling the sap, right? They were urinating and defecating, and their saliva was also getting into the sap pots. And if they wrapped those with bamboo skirts, then the bats couldn't get in. They were less interested. They went elsewhere. They didn't urinate and defecate and lick the sap. And guess what? People didn't get sick. So a win-win. Less disgusting, for one. And disgust is a huge behavioral motivator for people, more than illness, disgust. So finding those motivators was another success story of this Nipah story, that we need to think differently about how we do risk communication, how we think about behavior change. And again, this pandemic is showing us if we can actually weaponize health, first of all, let's not do that again. Because then more people die. And we need to figure out what does motivate people to take a personal action and change to protect themselves and the people around them.
The date bomb story is a fascinating one. It wasn't in this case a carrier, but I was talking to Thomas Hildebrandt at Leibniz, and he's breeding or trying to breed the northern white rhino, and he had this very interesting chain of this rhino. I forget what the quantity was, but the amount of poop it made every day, and there was worms that live in that, and then dragonflies eat the worms, and you know what? Bats sweep down and eat the dragonflies, and when you kill off all of this one sort of megafauna in the chain, you can have detrimental effects when the bats need to fly away and go elsewhere. So I think there's some really sort of sort of elegant stuff that potentially we could all be doing that isn't diagnostic, vaccine, or drugs, that keeps sort of the balance. Once again, I found that very an elegant sort of example as well.
And bats are really important, and that's one thing if you don't mind, I'd just like to share that. Sure. Also during the PREDICT project and my own other science, we've worked a lot around bats and when they shed, and trying to find out an elegant solution to preventing disease transmission, because they are shedding or giving off the virus in a way that it's transmissible to other hosts like people. But not hurt the bats. And there are reasons for that. I understand why some people would say, just get the bats away from me. I want no bats around me. They seem to carry lots of diseases. And really, bats are super important. They do control the pests. In this case, I wouldn't call the dragonflies a pest, but they eat insects that can be really problematic and also carry diseases like mosquitoes. Other bats are seed dispersers. And as we fragment the landscape, humans just break up these places where there are, endangered species, trees that need each other to reproduce. The bats are helping. They fly over the people and bring the seeds from one fragmented piece of landscape to the other to keep those species going that are so important for food, oxygen, everything we need on the planet, aesthetics, so that we can enjoy our life on the planet too. So what we found was that bats tend to shed coronaviruses, and we did multiple studies on this, that they tend to shed coronaviruses and make them available to people most often right when they're weaning their babies. So we call them pups. So when they're weaning their pups is when the moms are urinating and defecating out the viruses and making them available to the babies who have waning antibody, and they can get infected. That keeps the virus life cycle going. It's a great strategy, but it also gives us a clue to a more elegant solution. So if we can't limit completely our contact with bats, because sometimes they live in colonies of millions in urban centers, we can do some protective measures at that exact time where the risk is highest. So we can sort of rope off the areas where the bats are and keep people from walking under them just in those few weeks that the shedding is the highest, and dramatically reduce the risk of spillover. In other areas, we can reduce tourism or guano harvesting, other industries that are around bats and their products, just when the risk is the highest. And that's what doing this kind of work that we did in PREDICT, where you actually detect and map the timelines as well as the locations of these virus shedding events, can be really, really important for control.
Jonna, the One Health, sort of the Workforce Next Generation initiative, in this project, the purview is a little broader, because here you not only talk about zoonotic, but sort of much broader and sort of antimicrobial resistance, things of this nature. I did an episode recently on TB, and here we have something that's really, it's amazing when we think about tuberculosis, in the sense that our vaccine is 100 years old as of this year, has whatever 50% coverage. Our antibiotics for tuberculosis are from the 1940s, and the new tuberculosis vaccine is not estimated to be around till like 2030 or so. It's some crazy numbers. Talk a little bit, but first about the One Health for the Next Generation initiative. But are there things that we can learn from Operation Warp Speed or some of these other vaccine antiviral development initiatives that we can utilize some of these other, because 1.6 million leave this world every year due to tuberculosis. We don't think about it, but how to get these back on the radar, and how can we shorten some of these time frames?
Well, one thing you just said, if I could just refine it a little bit, is 1.6 million leave the earth and we don't think about it. That's human nature, and that's our biggest obstacle. We get used to things. So just like people have stopped getting influenza vaccines because they are just used to the flu that mostly doesn't kill people, right? That is a human condition that I'm very concerned about from this pandemic, is that this pandemic told us, showed us, brought it home to everyone that we needed to be ahead of these things and be ready for them. But as the time goes on and everyone is fatiguing of the talk and the discussion, we are seeing the momentum for doing things differently, better, more integratedly start to wane because people are tired. And so I appreciate that you're doing this show, and I really like working with people in communications, and we need to work with government. All of us need to work together on government to maintain the momentum and the political will. So sorry for sort of going on a tangent there, but I think your topic was super important. The One Health Workforce Next Generation project is a sister project of USAID's Emerging Threats Division, and I think so critically important, because it is creating the next generation of thought leaders, of implementers, actually working with more than 100 universities in Southeast Asia and Africa through two networks called Siahun and Afrahun, the university networks in those two regions, really providing the model for what can be done in One Health, and that you don't have to have every single discipline in your university if you network out to other universities. And so the idea is to bring this collaborative, transdisciplinary concept into early education. So we mostly had been focusing at the graduate level, but now we're talking about in this program at the undergrad level, also in service for people who are already working in government and other institutions, to say, okay, we need engineers, and we need them to understand enough about health and to be respectful to other disciplines that they want to work with the other disciplines. We need, of course, nurses, doctors, epidemiologists, veterinarians, but we also need sociologists, and we need pharmacists, and we need economists to all work together. And so that's really the goal of this huge program from USAID, is to infiltrate the educational systems with the curricula that make them better collaborators and better thought leaders, thinking more holistically. And I should say, as I took on this new vice provost role, I did step down from the project as the director, and the PI, Professor Valtrina Smith, is the new director, and I'm now serving on the advisory board because I think it's so important. And the best thing we can do for the future is make sure we have those professionals out there by the thousands that are infected with the One Health approach.
Absolutely. John, now going in a slightly different direction. Global Virome Project, it has a vision. I have a few extra $1 billion here. I'll give it to you, and you can go find those 500,000 or so viruses. Great. And we'll vaccinate and do all sorts of cool things.
If only. That's not the way it's going to happen. But
well, whatever. Yeah, I have $1 trillion. Yeah, I'll just give you some money. But on the other side of this, and I'd love to get your thoughts, where we could be going with all this. I spent some time also in the past with folks like Chip Schooley out at UC San Diego, who's, very active in bacteriophage viruses and their beneficial applications. I spent some time with Jack Stapleton at University of Iowa looking at beneficial viral co-infections, where you have this hepatitis G thing that for some reason reduces the the amount of herpes outbreaks that someone has, and all these very unique dynamics that happen. We understand very little about the human virome. You know more than I do, but that on one hand, there are, without the viruses, you and I wouldn't probably not be here, and we have lots of them within us right now, keeping us healthy. I'm going to give you that $1 trillion to do the Virome Project. What do you want to do? Big pot, sky thinking about all the beneficial stuff that we can learn from the virome.
And let me be clear, I'm not an antivirus person. I don't want to reduce biodiversity at all on this planet.
And I'll add one thing to this. I always feel great the day after I get over a virus infection. I don't know if there's something, whether that's an inflammatory response. I don't know what it's about, but anyway, go ahead.
Okay. Well, we should figure out what that is. And
there's something therapeutic there. You have to have a stomach virus that my kid gives me. Oh my God, I feel awesome the next day, but go ahead.
Okay. Well, it's important to remember that viruses don't leap out and attack us, right? Many, as you said, are part of our microbiome, though some will say they're not biological. So we will say the virome of humans, and we need them. And even those ones like the devastating SARS coronavirus 2 didn't leap out and get us. And the bats and other hosts didn't leap out and get us. It's our human behavior that puts us at risk. So I just want to make sure we're all on the same page, that it's our actions that get us infected and spread these viruses. So there are likely just as many beneficial ones. And some of those, you said 600, 800,000, that's what's in our paper. I've kind of adjusted it. I think it's going down a little bit as we discover more and more. We can start to refine those numbers. I'm using 500,000 right now, and the science will continue to improve and hone that number. Some of those that can infect us will be good for us. And we don't want to build vaccines for every virus either, because we know how long that takes and how expensive it is. Now, what I do think in sort of pie in the sky thinking is that we are capable of honing pipelines for novel viruses that are making us sick, killing us, causing huge devastation, and be able to jump in much faster. Now, Operation Warp Speed, big success. We've never seen vaccines developed and get to market at that speed. And I think our colleagues that worked in HIV/AIDS and tuberculosis and others have a reason to be, point out some equity issues around this one happening so fast versus others that have plagued us and continue to plague us and kill millions of people that are less effective or not even available, like for HIV/AIDS. So anyway, just thinking about that, we actually with Predict, we're already helping some folks by providing virus for them to test novel pipelines on, and now I think that will accelerate, and we will have better options for disease X. But while we're discovering viruses, and again, this is back to spillover and the global virome, I believe we have the ability to understand them better. So not part of that budget that I mentioned, but as science progresses, we invest in science and continue to do characterization. We can find the targets for those antivirals, those vaccines, that for just the ones that are hurting us and not necessarily the ones that are helping us. Without studying them, we will never know. We'll just sit here and we'll wait, and the next thing will come, and then we'll be behind the 8 ball and we'll have to start, all over again. And that seems to me to be, ridiculous at this point. Even surreal that we would consider that, knowing that we have the capacity to do things differently. We want to understand what makes viruses help us be healthy, and what makes them, what small changes structurally, genetically, everything that make them really dangerous. And we can't do that without looking at them and finding them first.
Absolutely. Jonna, you've, throughout this talk, you've mentioned people that have been with you along this path and been involved in these projects. I just want to give you back the floor for a little bit to shout out to some of these folks, because, obviously this is a collaborative on multi-fronts, multi-scientific fronts, but also all over, multiple countries. Take some time just to shout out to whomever you want that are been really influential in keeping things going here, whether they be scientists, investors, government officials, whomever. Please take the floor on that one.
Sure. I thank you, but I hazard to do that because I work with thousands of people on these projects, and they all are inspiring for me, and have just put their blood, sweat, and tears into this work in a way that I've never seen people do. So in the countries, the ministries that we worked with, we brought together the ministries of agriculture, environment, health, and other ministries, sometimes the tourism ministries, and the momentum that we saw from our amazing leaders in the countries was just fabulous. At the global level, some people I haven't mentioned yet that were critically important to this were Professor Tracy Goldstein and Dr. Simon Anthony, who led our viral detection and discovery program. Of a little fun fact there, we were initially not going to be responsible for doing the diagnostic piece or the viral work. And then it became clear that there was no one else to do it. And USAID asked us to do that as well, without a budget augmentation, and they made it work. I really think that they just did amazing things. Simon at that time was at Columbia University under Ian Lipkin, and Tracy was working at UC Davis. And as the world turns, Tracy is now the new Dennis Carroll. So Dennis Carroll, that visionary I mentioned,
Sure.
From USAID, he's retired and he's helping, we're working together on the Global Virome Project, and Tracy now is in his role at USAID, which I think is really amazing. And Simon is now a professor at UC Davis, so he's moved from Columbia. So one interesting thing is we're all mixing. I think some other sort of, just politically kind of devastating things, and I don't want to get into stuff, but our partner and colleague, Zheng Li, in China, was the head of our collaboration there at the Wuhan Institute of Virology, who has been very famously villainized. Our partner and lead at EcoHealth Alliance, Peter Daszak, famously had funding pooled just for doing exactly what he was promised to do in his NIAID work, and what was fully disclosed as the work that we would be doing there. So there's some people who have been working really hard to try to understand these viruses and discover them and put the information into the public domain just to be, clamped down upon. And I had a bit more quietly, but had some of those same really devastating investigations and harassment during this whole pandemic. So I'd like to give shout outs to them, Zheng Li, Shi, and Peter Daszak, for just fighting the good fight. And, none of us are perfect. There are all things that we do and say that aren't always exactly in hindsight the way we would want to put things forward. But these people, the vilification of scientists who are trying to do this for decades to help prevent this to happen, just when it happens to become the ones that were pointed at. I mean, I can't tell you how devastating it was to have people pointing at me and saying that I caused the pandemic, because I was trying to do the work to prevent it. So there's just a lot out there. You mentioned Suzanne, they're wonderful people at Wildlife Conservation Society. So Christian Walter, Sarah Olson, Tammy O'Rourke, there's just so many people out there that have done a wonderful job. Karen Sailors at Labyrinth. So, I will forget people. My right hand man, David Wolking, really organized and saw us through to the end. So, I think I should stop so that I don't. I can give you the list. We have it online, and it's several hundred people long.
We'll link to it.
Yeah, and each of those people had 9 or 10 people working under them. So.
Yeah. Well, John, it's really fascinating stuff, and I completely agree with you. We cannot go over to the scientists and the clinicians that are keeping us alive and keeping us safe, and that's a horrible situation that you and others have had to go through. But I want to help on our end by fighting the good fight and keeping the word out there about all the benefits, everything that you and the hundreds that you mentioned are continuing to do to keep us safe, and really wishing you the best with all of this. For everybody that's going to be listening to this particular episode on the podcast or watching on the YouTube channel, you've been listening to Dr. Jonna Mazet, Professor of Epidemiology and Disease Ecology at UC Davis School of Veterinary Medicine, Founding Executive Director, UC Davis One Health Institute, and also Provost. What's the new role?
Vice Provost of Grand Challenges. So
I
look forward to, attacking these and the other things we're fighting, especially diversity, equity, inclusion issues. In California, we have wildfire problems, the climate crisis, and how those are all connected, and they are.
Outstanding. Jonna, thank you for taking the time out of your schedule to do this. Thank you again for everything you're doing. And as we say on our show, thank you for helping to create the better tomorrow for all the rest of your work. It's really very impressive.
And thank you, because what we've learned is we need to be in partnership, and the communication, scientists need to do better. And thank you for helping us do that.